Hello and welcome to an AP Stats test review for the 5-number summary and outliers. Typically just what I've seen over the last 8 years as far as AP testing, more closely looking at free response, is usually either the first or second question deals with descriptive statistics. You take a univariate data set, generally they'll ask you, a lot of times they give you a graph and they'll ask you to describe it using SOX, shape, outlier, center, spread, or they'll ask you to compare a couple distributions or just to take some particular information about univariate data and try to use your statistical knowledge to come to some conclusion or choice. So for the first AP Stats review, I've chosen to talk about the 5-number summary and outliers, box plots. They're generally multiple choice questions that deal with those topics as well as FRQs. So let's do some vocabulary review first, starting off with quartile 1. Just like when we split $1 into 4 equal parts, we call them quarters. 1 quarter is 25 cents and so on. We do the same thing with data sets. So if we call it quartile 1, and quartiles divide in order to list of numbers into 4 equal parts, with quartile 1 representing what's called the 25th percentile, or the first fourth of your data set when it's ordered from least to greatest. And then we've got quartile 3, which represents the 75th percentile, or which will be the first 3/4 of your data set. The median is also known as Q2, quartile 2, and it represents your 50th percentile. Cuts your data in half. Half of the values fall below the median, half are above the median. And then let's talk about some outliers. There are extreme values that differ greatly from other data values in your data set. And in a minute, I'll show you a more visual representation of quartiles. Interquartile range. Think of inner quarter. It's inside. It's the middle 50% of your data set. And it's also called IQR. It's your quartile 3 minus quartile 1. And then what we can do when we want to check our data set for outliers, we're going to use what's called the 1.5 times the IQR rule. And that states that any value that is more than 1.5 times the IQR below your first quartile and above your third quartile is considered an outlier. So let's now put some visuals to what we just did. Quartile 1, I'm going to highlight that and let's go yellow. All right, so let's say that these are test scores. So here's my lowest test score, and I'm going to stop right here at the beginning of the box. That highlighted area represents the first 25% of my test scores. So this value right here, right at where that box starts, that's quartile 1, which looks like about 40, maybe 45, 46. So this would be the first 25% of my data values would fall in that range from looks like, 22-ish to about 46-ish. All right, so now I'm going to switch highlighter colors. Let's go with green for the next one. We'll talk about quartile 3. So that would be from your min up to the end of your box. All right. So values starting at about 22 all the way up to 90 would be quartile 3, which would be the end of my box in my box and whisker plot. So that's 75% of my data lies within that range. And then the remaining 25% would be from your quartile 3 to your max. And let's now take a look at the median. Do that one in blue. That's going to be from your min to your vertical line in your box. And that there represents 50% of your data set is within that range. And this value right here, right at about, looks like 72, that's going to be your median. Median's always expressed as a vertical line going through the box in your box and whisker plot. All right. Also, your interquartile range would be the middle 50% is your box. So 50% of your data is between Q1 and Q3. Okay, let's explore these concepts with the following data set. It's just a generic data set, but just to put some context to it, we can think of them as test scores. Now, I'm going to first do this old school. It's only 10 values, so I'm going to actually order the list, find my median, my Q1, and my Q3 by hand, and then I'll show you how to use a calculator technology to do it. I'll be working with a TI Inspire. TI-84 is very similar. Plenty of YouTube videos for whatever calculator you have, as long as it's a graphing calculator with data and statistics options on it. You will be able to do the same things with your calculators. You just might have different steps that lead you to the answers you need. So I've got this data set, and in order for me to find my mean and standard deviation, or my median, my Q1, my Q3, I need to order this set. Okay, what's going on here with my pen? All right. So I'm going to go ahead and put them in order. Easy way to do this, cross them off as you proceed through the list. So make sure you account for every number. I can also, for those of you that have Inspires, I'll show you how to order the list on your calculator, make it a little bit easier for you. If you want to still do it by hand, but take some of the guesswork out of it, or work to put them in order. All right, I should have all 10. No, I don't. 101. Make sure those are right. Oh. Just misread that. There we go. Okay, so I have my ordered list of data. Now we're going to find the median. You've probably been exposed to this previously in middle school or elementary school, where you give you a small data set and they say find the median and you cross it off end to end, but you can do that. So my median, since this is an even number of data values, it's going to be the average of my two values in the middle. So it's going to be 58.5. If I add 58 plus 59 divided by 2. So there's my median. Now to interpret that, you would say 50% of my data values fall at or below 58.5. All right, calculate the range and interpret it. Well, the range is going to be my maximum value minus my min. I threw the range in here because when we describe a data set, part of spread should be the range. Shouldn't be the only part, because range with outliers can be not a very good or accurate representation of your overall behavior as far as spread. So max minus min, so that's going to be 101 minus 41, which is 60 units. Because a generic data set, I'll just use units. Now, so you would say the data set has a range of 60 units. All right, let's find the first quartile and interpret it. Well, ultimately, all you're really doing is finding the median 3 times. So I'm going to go ahead and highlight the first half of my data set in blue. Okay, and now I'm going to find the median of the first half of my data set. That will be my first quartile. right, so the odd number, I'm just going to circle my middle value. That's my Q1. So now I'm ready to interpret that. And remember, Q1 is 25%, so 25% of my data values fall at or below 56. Okay, now I'm going to highlight my second half of my data set in like a pinkish color. Now, if I find the median of the second half of my data set, that's quartile 3. And there's my Q3. And I'm ready to interpret it. Remember, 75th percentile, so 75% of data values fall at or below 60. Okay, now I'm going to calculate my IQR. Remember, the IQR is your middle 50%, which is Q3 minus Q1. So 60 minus 56 is equal to 4 units. All right, so the middle 50% of this data set, of values in this data set, span 4 units. Just like the range is expressed as one value, not my data ranges from here to here, my interquartile range is also expressed as just one value, the result of that subtraction problem. It's really not accurate to say my interquartile range is from 60 to 56. It's 4 units. It spans 4 units. All right. Now we're going to use the 1.5 times the IQR rule to find the upper and lower boundary of what I call acceptable values, values that are not considered outliers. So we already have the ingredients for these. So my lower boundary of acceptable values is going to be quartile 1 minus 1.5 times my IQR. Quartile 1 is 56. Our IQR is 4. My lowest value, and it doesn't have to be a value that's necessarily in your data set, but the lowest value that could potentially be in our data set that would not be considered an outlier is 50. Now our upper boundary of acceptable values is going to be quartile 3 plus 1.5 times my IQR. Quartile 3 is 60 plus 1.5 times 4 again, and we're going to get 66. So any values from 50 to 66 inclusive, and everything in between are not outliers. Anything below 50 and above 66 would be an outlier. So now you'd go back up to your data set, and you would take a look at it, and you would note any values that are below 50. So I have 2. And any values above, 66. Okay, I'm right. It's 101. So I have 3 outliers in this data set. I have 2 lower ones, 41 and 45, and I have an upper at 101. And I believe that's the next couple questions asked. How many low outliers? We have 2 low outliers at 41 and 45. And we have 1 high outlier at 101. Now, to create a graphical display of this data set, a box plot is a graphical display. So we're going to go ahead and create a box plot. And you have to label your, it's just generic, so I'm just going to call it data set. All right, I'm going to use a different color. I'm going to do my outliers in red. So outliers, when you graphically display them, they're dots, stars, or asterisks, and they're not technically part of the box and whiskers. So we have one at 41. I also like to at least put in my 5-number summary as well above the values. I got another outlier at 45. My lowest value that's not an outlier is 56, but that's also my Q1. So I won't have a whisker on my left side because the lowest value that's not an outlier, which is what my whisker would extend to, and my Q1 are the same number. And then we have medians at 58.5. So this is 56, 58.5. Then we have 60 is our quartile 3, and then our lowest value that's not an outlier is 66. And we have another higher outlier at 101. All right, so normally you would take your whisker from your lowest value to your quartile 1, but again, those are the same. So I'm going to draw a box around Q1 to Q3. Draw a vertical line through my median, extend my whisker to 66. It's the highest value I have in my data set that's not an outlier, and then I am complete. I've completed my box plot. Now what I'm going to do is show you how to do this with technology. So just to save a little time, I'm going to make this a little bigger. This is a TI Inspire, if you've never seen it before. It's a great calculator. You would have to go to List in Spreadsheets, enter your data set, name it in the alpha cell. I named it box plot. Enter your values, double check to make sure you've entered your values correctly. And then I'm going to do stat calculations. This is pretty similar to the TI-84. So I'm going to go to Menu, pick Stats, run some stat calculations. This is one variable univariate data. I just have one list I want to run calculations on. My X1 list is going to be, I forgot what I called it. I think I called it DS. Nope, I called it box plot. That's going to be the wrong data. That's okay. I'll run it again. Give you some more practice. Oh, you know what? That is the right data set. Nope. Yeah, it is. Okay. Sorry about that. Okay, so I'm going to run that one more time because it's based on, I named it box plot. So it's menu, stats, stat calculations, one variable, one list, and I'm going to make that box plot. Okay. So now if you, there's my mean, 60.3, but I want my 5-number summary, which is my min. That's not right. Oh, that is right. Sorry. My min is 41, my Q1 is 56, my median is 58.5, my Q3 is 60, my max is 101. There we go. And that corresponds with what we got in as far as, let me go back. There we go. Min, Q1, Q3, max. Okay, now I can also make a box plot with the TI calculators, the graphing ones. On the Inspire, I go to the data and statistics icon. I click my x-axis. I want to make a box plot on box plot data set. Now it's a dot plot currently. I want to change it to a box plot, so I'm going to go to Menu, Plot Type, Box Plot. And as you see, I got a very similar scaled. It looks like it's scaled a little differently, but there you go. And if you hover over these values, it'll actually give you, that's 41, that's 45. There's my Q1, my median, my Q3, my highest value that's not an outlier, and my max. And it shows the outliers as dots. And that's how you would do it on the TI Inspire. So, also we're going to describe this distribution. So let me go ahead and... Now when you describe a distribution, you should use the acronym SOX to remember every aspect that you need to totally describe a distribution of univariate data. The first S stands for shape. Now, looking at my graph, the way box plots are not necessarily always the best graph to determine shape, but you can get kind of an overall feel for it by looking at your median to your min. That's looks like about 17.5 units. And the difference between my median and my max is more like probably 41.5. So we can see that the right side of my distribution is much more stretched out. So that would be a right skewed distribution. So, and you know what else you can do to determine that? Compare your mean and median. So I'm going to go back and I'm going to take a look. Okay, my median's 58.5. My mean should be higher than that, and it is at 60.3. And then what happens is that 101 is pulling the mean up away from the center of the data. That's why the mean's not really a good representation of the center when you have skewed and or outliers. So our distribution is definitely right skewed. What's going on here? Sorry about that. Okay. You know what? This is not cooperating right now. All right. I'm gonna just write it. Okay, so remember, it's SOCS, shape. Talk about the shape of the distribution first. Then I usually do center second, and that's going to be either your mean or median depending on the shape of your distribution. This is spread. And then last I always talk about outliers. So the shape, the distribution is skewed to the right. I know that for two reasons. I can tell from the distance from the median to the max and median to the min, but I also know the mean's greater than the mean. The mean is greater than the median. The data is centered around 58.5, and I'll note that's the median. The middle 50% spans 4 units and ranges, the data ranges, data has a range of 60 units, and then I'll also, which is 41 to 101. Oh, and then there are 3 outliers. At 41, 45, and 101. So there's a nice descriptive, thorough description of this data set using shape, outlier, center, and spread. Now, these 2 questions from previous AP statistics tests require this knowledge of box plots to answer correctly. I recommend that you do the questions and use the College Board rubrics to assess your understanding. Number 1 from the 2015 and number 1 from the 2008 FRQ test, you can find these at this link down here. If you go to, most of you have been to College Board, go to College Board, go to statistics, And they'll give you a list of every year's FRQs, and you want to go to 2015 and 2008, do number 1 from each one of those. Again, use the rubrics to assess your knowledge and clean up any errors you made. And you'll see how you can use this particular knowledge to do these 2 questions correctly. Thank you for joining me, and I'll see you at the next review.